All right, so limiting reagent helps us find what's limiting, and then we got to think about as we get product, are we getting the amount of product we should get out in a reaction? And that's what we use percent yield for. So percent yield is an actual equation where you take actual yield divided by theoretical times 100%. So actual yield is what you get in the lab, or it'll be given to you in the problem. And obviously in the problems, that has to be given to you. Um, Theoretical yield, on the other hand, is calculated by using the limiting reagent. So you have to find limiting reagent, and then you use limiting reagent to find theoretical yield of your product. And again, I will do an example of that so you can see how a percent yield problem works. And here's the example. So we got 100 grams of nitrogen gas and 25 grams of hydrogen gas, and they're mixed at 350 degrees and at a high pressure. They react to form 28.96 grams of ammonia gas. That's called the Haber process. And we are going to calculate the percent yield. Do it now. Okay, percent yield. So the first thing I did is I wrote out the balanced equation and I found the molar masses of everything involved. And then now we'll look. So if we want to find percent yield, the first thing we have to do is find which one's limiting. So we know how that works. We have 100 grams, 100.0 grams of N2, and we have 25.0 grams of H2. And then we take that and find limiting. So we want to see which one's limiting to make the ammonia. So we take 100.0 grams of N2. The molar mass of N2 is 28.01 grams of N2 and 1 mole of N2. I then know I got 1 mole of this to 2 moles of this, so 1 mole of N2 to 2 moles of NH3. And then lastly, I want to go 1 mole of NH3 is 17.03 grams of NH3. So there's all my work. Bring that calculator back up. 100 divided by 28.01 times 2 times 17.03. And I get 4 sig figs, so 121.6 grams of NH3. So that's how much ammonia I get if I use up all the nitrogen. Now the hydrogen gas, I got 25.0 grams of H2. My molar mass is 2, so 2.02 grams of H2 and 1 mole of H2. And then I go 3 to 2 ratio, 3 moles of H2 and 2 moles of NH3. And then molar mass, so for every 1 mole of NH3, I got 17.03 grams of NH3. And then we solve, so 25 divided by 2 times 2 divided by 3 times 17.03, I get 141.9 grams of NH3. So my limiting is this, which means when I run this reaction, I'll get this. So this is my theoretical yield. Now it says you get 28.96 grams of ammonia. So that's going to be our actual yield. So actual is given to be 28.96 grams. So now percent yield is actual. So percent yield is actual divided by theoretical times 100. So our actual is 28.96. Our theoretical is from our limiting reagent, 121.6 grams times 100. So 28.96 divided by 121.6 times 100, and I get a yield of, it's like we got 4 sig figs, 23.82%. So, percent yield problem, find your limiting. Whatever your limiting turns out to be, that answer is your theoretical. The actual will be given to you. Either you get it in lab or you'll be given to you in the problem. Actual divided by theoretical times 100 gives you percent.